we are still in Rajasthan in a very interesting geographic place, and again Professor is here, Professor Stephen Tooth, the dryland geomorphologist, and we are seeing here, as you can see, a lot of carpet of black stone kind of things, and we will try to understand what are these things from Professor, please.
Okay, so the feature we're standing on it goes by different names in different parts of the world. The most common term in the English language is a desert pavement. In parts of North Africa they might be called regs. The Australians might refer to them as a gibber plain. But essentially we'll stick with the term desert pavement. So what they're formed by breakdown of the country rock, essentially, and the products of that breakdown and the weathering, the coarser products tend to concentrate on the land surface. The finer material is often winnowed away by the wind, or it infiltrates between the larger class. In some cases, larger class can come up from depth. Essentially, if you were to think of a packet of cornflakes and you were to gently shake it, the finer particles would fall down between the bigger ones, and the larger flakes would remain on top. And sort of with heating and cooling and wind action and rainwater action over long periods of time, the coarser particles tend to concentrate at the surface, and they often pack quite tightly together. And actually, if you remove some of them, I'll remove this one here, you'll see that it's pretty stone free in the subsurface, and there are small holes.
Yeah, if James can come here and show us the holes.
These are known as vesicles.
Mm-hmm.
And they're sort of small holes that go somewhat vertically down into the subsoil. And that's just to prove that's not a fluke. Let's lift another one. There's some small
Everywhere,
ones there.
yeah, you can see that everywhere.
Oh, it's good.
Wow.
Good set of examples there.
Yeah. So is this the bubble that's forming inside that, the air that was trapped, it's pushing it?
Yeah, that's.
Like that?
I think that's a theory. When rainfall falls on the land surface, it obviously tries to infiltrate into that land surface. On a relatively flat surface like this, it doesn't flow away particularly easily. It tries to get into surface, and some of the rain does penetrate small holes and cracks, but of course there's air inside, and it displaces the air from inside, and the air pressure increases. And I think my understanding, and perhaps I've got to go back to the desert geomorphology textbooks to find out, some of the vesicles form as a consequence of that air being forced out.
So talking of rainfall and stuff, we know that there is a really large lake over there, kilometers long, lake, and in an arid area where water is scarce. So do you think that there is something to do with this pavement kind of a structure that is increasing the runoff or something like that?
Certainly desert pavements overall do tend to maximise runoff you can expect from the land surface. So, ballpark figure here, typically some 70 to 80% of the rainfall landing on the land surface would run off as overland flow. So potentially it can collect in topographic lows. First of all, it probably enters some small ephemeral channels which flow and will flow towards topographic depressions. But there is a lake over there. If Jayesh pans around, we can see lots of irrigation agriculture that's come into this area over the last decade or two, and that's probably contributing to the supply of water to some of these lakes as well.
Yeah. So I want to understand this thing, like why they are spread like a blanket. They were like in situ rocks, they got broken, and then, but why there is a uniform layer of there? So
the weathering of the land surface, in an earlier video we talked about the jewellery crusts that form, the ferricretes, calcretes and gypcretes in some cases. So they form as a layer on the land surface, and then that layer will gradually be broken up with time. We're on a kind of a flat-lying surface here, so I suspect the clasts that we're looking at here have not moved very far at all. They've probably just broken down and are in situ. Lower parts of the land surface, of course, some clasts can be rolled down the sides of the hills and can collect on lower-lying land surfaces, but I think what we're looking at here is the in situ breakdown of the rock.
Okay, so it was lovely being here and talking to you, Professor, as usual. See you next time. Bye-bye.